Hi everyone, I am Apurva Dani, and today I'm going to talk about the project that I've been working on. I have worked on the project of emulating Firebase using Flask and MongoDB. So the video is structured in a way that we will go through the data set first, the architecture that we have used. We will go through some pieces of the code and the way we have structured the code. And the last part would be like go through a live demo, which would cover almost all the functionalities that are being supported currently. So let's start right away. I will first talk about the data set that I have been using. So I have used the rental pricing data set, which basically has the information on rent pricing surrounding Kuala Lumpur and like the region around Malaysia. Um, the just to give some idea about what the data looks like, there are 13 features for each row. We have ads ID, which is the unique primary key. You have the property name, you have the completion year, the year in which the property was completed, what is the monthly rent that has been posted in the on the website or in the advertisement. You have the location, I mean the property location, what is the type of property, is it an apartment, is it a flat, is it a duplex, is it a studio, etc. It also has a number of rooms. It also tells you if there are enough, like the number of parking space in the unit, the number of bathrooms, the size in square feet for the entire area, if it is furnished or not, facilities, and also some additional facilities. Something to note here is this facilities and additional facilities can have multiple values. So this is an example of the type of values that we have in each of the columns. So you have this unique ID for ads ID, you have the name of the property, and different types of properties. Is it like a condominium? Is it an apartment? And area and a lot of other stuff. So this is the data set I have been using. It has around 20,000 rows of observation, and the size of the data set is around 5 megabytes. So this is something to just notice. So we're working with a good chunk of data of like around 20,000 rows and 5 megabytes of size. So yeah, this is the data set I have been using. Now let's try moving towards towards the architecture that I have been using. So one second, let me just take right. So the architecture that I have used, so this is the final architecture of the entire project. On the left side, you have the user who will make a curl request using the command line interface to the Flask server. This Flask server has several endpoints, and it will listen to this request if it is like a get request, patch request, and accordingly convert that query into a MongoDB query. We send a database request to MongoDB. The output is received from MongoDB to the Flask server. We convert that into um, basically we convert that into a format, into a JSON format, and then we return that server response to the command line interface and finally to the user. So this is the architecture that I have been using. So the first part of this is to basically load this data set, the Malaysia data set in MongoDB. We would go to that after I like go through some pieces of the code first, right? So let's dive into the code. So this is the structure of the code that I have. We have the data folder, we have the CSV JSON file, we have insert data, we have a Mongo class, a query class, and the main server file. So first I will go to the data folder. Here we have downloaded the apartment data from the Kaggle website, which I just showed, and it is downloaded in CSV format. So to load this into MongoDB, there were a couple of steps which we had to perform. One was first we used the CSV JSON file to convert the apartment CSV data into the JSON data. So this is the file you can use to convert that into a JSON file. And then we have an insert data file, which basically reads the JSON file that was created here and pushes it into the MongoDB database. So this is the data structure that we have, and these are some of the other utility files. Now I would dive into the server.py file. So in the server file, we have used PyMongo to connect to the Mongo client. And basically what is happening in the server file is we have listeners for each of the different methods. So we have a listener for a get method, for a put method, post method, patch, delete. So these are the listeners that we have. What this does, the path X, it basically gets the entire query that we have in variable X that are trying to make a get request. So all of those are basically run in this function. So we have different functions over here. Another important class that I have designed is the query class. So in this class, we initialize the object with a particular query and a collection. So this is basically the query which has been sent through the command line interface uh, to the Flask server. So just to give you some context, so in this, as you can see, once we get all the required out input from the command line, we create a query object and we pass that particular query to this class basically. And it has a very important function which is the parse query function. The main idea behind creating this function is to basically convert all the queries into different key and value pairs, right? So for example, if you have like a get method with the URL, so you would like to know what is the collection name, what is the query path where you need to go. So all of those things are basically stored in the parse result dictionary. So as you can see, we have parse result of collection, you have status, you have query path, etc. The status is basically used to find out if the query was successfully parsed or not. So there can be several cases wherein if the user has typed queries which is syntactically wrong and things like that, in those cases, we would basically set the status as false and return that back to the server file. So this can be then used to verify if we want to move ahead or if we want to throw an error to the user. So this is what we have done for the query class. We also have like some other functions which are like utility functions to like verify the collection and convert a list to dictionary and etc., which are like not super important, but there are some utility functions that we have designed. Another important class that we have designed is the Mongo class. With the main idea behind designing this class is to get the user query and convert that Firebase query into a MongoDB query. So as we have seen previously in the get function, once you receive the input, you parsed the query. So we have all the key value pairs that we need. We know what path do we want to go to, what is the collection that we want to go into. And then we have used the get, like we have used this class to basically initialize all of it, pass that parsed query to this class. And then this class has all the different functions which are like get, and we have all the logic to basically, if we want to like limit to first, if we want to limit to last, if is there equal to start at, end at. So we have covered all of those cases. And once we have all of that, we have formed the actual query, then we basically send it to the MongoDB database, get the result out, and then pass this back to the Flask, the main server file. What is happening here is again like status, result of status. That is something that we are storing. So in case the result fails, or maybe the collection is wrong, or if there's any error in the MongoDB, we we say that the status is false, which basically means that the query could not be successfully executed. So we can pass an appropriate response back to the user. So this is what we have been doing in this Mongo class. So we have a get function, and then we have a put function, and you have basically a patch, a post. So something that we have done smartly is in the post function, we are calling the put function itself, but we are basically adding a random key before it, because post function is similar to put, except that we have a new key which is generated. So that is being handled in this particular part of the code. And then you have a patch, a delete function, and an important function that I would like to go through is the create index function. So in this function, basically what is happening is uh, if you have like if user is trying to make a get request and it has an order by key, and if that is not indexed in Firebase, it throws an error. So that is what we try to replicate here. If the query, if we do not have that in the index, we throw that error. So the user has the freedom to create that particular index using the patch query. And that is being basically handled by the create index function that we just saw in the Mongo class. So these are some of the this is like the code walkthrough. Now I think we would like go through the we'll go through a live demo. Let me just bring up the screens, the queries. All right. So first of all, let's just try to first 1 second. Yeah. So what we're trying to do is first, as I mentioned, we have the insert data file. So we're trying to insert the JSON data that we have into the MongoDB database. So we are trying to run this function. Once this is done, we can see in the MongoDB file, let me refresh this. We have an apartment database with listings collection, and this has all of the data that we want. It has the ads ID, the prop name, and it has basically loaded all the 20,000 rows inside this MongoDB database. So this is how the data is structured. This would be useful when we are trying to go through the queries and see the results. So this is how the database is loaded in MongoDB. Now let's just try to start the server file. Yeah, so the server is running now. I will just minimize this. I mean, this is not important right now. Let's first just like try a simple get query, which gives us the idea about the data that we have in the database. So as we can see in the in the in the get query, you have this additional facilities which is stored like a dictionary, like a JSON file object, which has like the facility and like like the ID and the facility. Then again, you have all of the ads ID, the bathrooms, the completion year, the facilities, if it is furnished or not, and all the other attributes that we just saw. So this is how the get query is working, and this is the data that we have in the database. Now let's try to basically um, run a query which will order, and which is like a little complicated, a little complex get query. So in this query, what we're trying to do is we are trying to order all of the 20,000 rows based on the number of rooms they have, and we want to limit to last, which is equal to 1. So something that I would like to make a note here is that the maximum number of rooms that we have in this database is 10, wherein they state that like more than 10 rooms, and that is the final, like we don't have any other um any other data which, or any other row which has like more than 10, like anything greater than that. So for this, we are expecting a result which will have like one output, and the number of rooms that will be like more than 10 rooms. That is what would be the value of that particular attribute. Oh, so I mean, as you can see, when we're trying to do this, since we have not set an index on rooms, this throws an error saying that index is not set on rooms. And because of that, we cannot run this query directly. And we first will have to create an index for rooms. So as I just previously displayed, we have this function which could be used. So let's say so this is a patch query. Can be used in Firebase to basically can create an index using curl commands. We are going to basically use the same query for our own server, and we have provided support for this kind of query. So in this query, what we're trying to do is we are sending a patch request, and the data that we have, it says that we are going to index on this variable, which is rooms. And yeah, and this is like our URL. So I'll do that. It says index is now successfully created on room. So if this is true, we should be able to run the get query that we ran before, and let's see what the result is. So as you can see now, since we have limit to last equal to 1, we only have one result. And out of this one result, we can see the number of room states like it is more than 10. And this is the maximum value we have in our own database. So this seems to be working fine. Let's move ahead. Let's try to run another get query. And in this get query, you you are basically saying order by completion here. and you want to start at 2020 and end at 2022. So the all the results that we have should have a completion year between both of this. Let's try running this. Again, it says that since it is like you're ordering by completion year, but it is not indexed, we would have to do that first. So let's try to index this first. I have a command ready. So let's do a patch query to do this. I'm sorry, let's try to run this again. Yeah, 1 second. So we wanted completion underscore year. And I'm just rewriting the query. I think there's some issue in copying the query in Word. So we would like to order by completion year. So as you can see, it says now index is successfully created on this particular column. And now we can try running this. Again, the results that we're expecting is that all the answers that we get should have the completion year between 2020 and 2022. So let's try running it. Cool. As we can see, the completion in this query, in this result is 2021. And even in this, it is 2021. So it basically satisfies that your results should be between 2020 and 2022. So this is how the another get query worked. Now let's move on to like the put query. In this put query, what we're trying, so like just to give you some idea before that, let's just try running the get again. Yeah. So in the put query, what we are trying to do is we want to basically add so we are basically trying to update the new facility with a value of pool table. And right now you can see that in facilities, we have all of these different 10 facilities. And since it is a put command, all of this should be replaced and it should only have the new value, which is pool table. So let's try running this. It gives this as the output. And then let's again try to get the zeroth data. And as you can see in the facilities, it has been now replaced by the new facility, which is pool table, and all of the previous facilities have been deleted since this was a put request. So this is some of my, this just to like give you some idea around put. We can also try running another put query. So let's like run another put query. So just like right now you can see in the additional facilities, you have 0, 1, 2, 3, 4. Now when you try to run this put query and then see the JSON file, you can see that has additional facilities have been just replaced by bike riding and all of the previous values have been deleted. So this is how put is working with my code. Now let's move on to the post one. So in the post, what we're trying to do is we are going to basically let's take another data object. So we are going to make changes to the first object now. So let's just like have a look at the first object once. So this is the data that we have, and then what we're trying to do is we are trying to add again the new facility, which is pool table in facilities.json. And the result that we expect here is to add this new value with like a new key, and this should be added as the value to that new key inside the facilities column. So let's try running this post query once. And we see that this is the output. This is the new key that has been created and the value has been inserted successfully. So let's try getting the value, the first value. And as you can see in the facilities, in the facilities, we have this new query basically with the new key and the new facility, which is pool table. So this is how the facilities and the post function is working. Now let's move on to patch. Now what patch should basically do is add a new value without replacing the previous values. So right now in the patch function, we are again going to add value to the first object, the one object that we have, and we are going to make changes to this additional facilities. So right now in additional facilities, we have like air condition, cooking, allowed, near, etc. So if we run a patch query, it should just add here and it should not like replace all of it like it did in the post or in the put query. So let's run this patch function and then call the first object. So as you can see in this additional facilities, now we have added bike riding and this has not replaced the previous values. So this is how patch is working. Now let's like just go to the last one. Oh, I think we missed one other. Yeah. So let's try um let's try doing this thing. So what this is trying to do is it will try to add something. I mean add the new patch query to a key that does not exist yet. So this should create even the new key, the bikes key inside additional facilities, and then add this new value inside it. So right now, as you can see, we do not have a bikes key here. We have like 0 to 5 key. So let's try running this and see how is that working. Let's try to get the JSON file. And yeah, as you can see, we have a new query bikes, and then we have added the new bike riding value over there. So this works fine. The last query that I would like to go through is the delete query. So again, like we will try to delete the bikes query that we just added and see if it gets deleted or no. So let's try to run this. Right now, I mean, just as I have shown before, we have the bikes and the bike riding as the value in the first object. We're trying to delete that, right? Let's see if that has been deleted. So as you can see, now you do not have that bike value inside this additional facilities for the first object. So yeah, this was my live demo, and this is the project that I have worked on. It was quite challenging working with like the MongoDB queries, converting Firebase into that queries, getting out the results. It was a fun project. I really enjoyed working on. If you have any questions over this, you can either mail me to my university's mail ID or just drop your doubt in the comment section of the video. Thank you.